We're going to explore the next method in calculating the volume of solid of revolutions, which is the washer method. In this method, the volume is equal to pi, the definite integral of the larger radius to the second power minus the smaller radius to the second power. Then you take the integral with respect to x. If the larger radius is denoted by function f or related to function f, you're going to replace that by f of x. And if the smaller radius is connected to function g of x, you're replacing that with function g. So in this case, you have two functions. One of them forms the larger radius, and the other one forms the smaller radius. So as you can see, if you look at the cross-section is not exactly a circle or a disc. It is basically a washer. The area of the washer is pi times the larger radius to the second minus the smaller radius to the second. Or basically what you're doing, you are subtracting the smaller area from the larger area. The region R is bounded by graphs of function f of x, which is square root of x, and function g of x, which is x squared. X is bounded between 0 and 1 inclusive. What is the volume of the solid that results when R is revolved about x-axis? So what are we looking at? The function square root of x is the top function here, and x squared, the parabola, goes down here. So basically, if you're revolving this about x-axis, the larger radius is located on square root of x, and the smaller radius is connected to x squared. So the inner radius is x squared, and the outer radius is square root of x. To calculate the area bounded between these two, it is basically pi times the outer radius to the second, which is f of x to the second, minus the smaller radius, which is g of x to the second power, which can be written as pi times square root of x to the second, which is your outer radius, which is basically this portion on top here, minus the inner radius to the second, which is x squared to the second power. So if we change the color here, this is basically your parabola, which gives you the smaller radius. So the larger area minus the smaller area. If you revolve this around x-axis, the object that you get is this three-dimensional object. So we take this guy and start revolving this or rotating this about x-axis. This can be written and simplified as pi x minus x to the fourth. So we found the area of the cross-section. Now we're going to use the volume formula and calculate the volume here. In washer method, the volume is pi, the definite integral of larger radius to the second minus smaller radius to the second. You take the integral with respect to x, or in simplified version, it is pi, the definite integral of f of x to the second minus g of x to the second. We already calculated these. Using Washer method, v is equal to the definite integral 0 to 1. And also the question says, hey, just focus on ranges between 0 to 1 of pi times x minus x to the fourth dx. We're going back to integral techniques. The integral of u to the n du is u to power n plus 1 over n plus 1 plus constant of integration. So this becomes pi x squared divided by 2. The integral of x is x squared divided by 2 minus the integral of x to the fourth, which is x to the fifth divided by 2. Then you plug in 1, you plug in 0, do the subtraction using the fundamental theorem of calculus, which gives you 3 pi over 10. So the volume of the object, three-dimensional object, is 3 pi over